friends, to the next module of the chapter where we'll be basically focusing sum based on Hess law. Let's start the sum. Question says, calculate the heat of formation of ethylene, and the heat of formation of water and carbon dioxide are given as minus 286 and minus 393.6 kilojoule per mole, and the heat of combustion which is given is minus 1423.6 kilojoule per mole. Now, since in the question two values have been given for formation, one value has been given for combustion, so we'll be using Hess law for solving that. Now, in this particular equation or sum, neither the required equation is given directly nor the equation which we have to use is given directly. So we have to create both. So let's first create the things which we want, that is formation of ethylene. Now, whenever there is formation of ethylene, ethylene will be formed from its element as carbon and hydrogen. So writing the equation as carbon plus hydrogen is giving you ethylene. Now, since it is formation of ethylene, we cannot change the balancing of ethylene. So the balancing part will be, it is 2 times the value of carbon plus 2 times the value of hydrogen is giving you 1 mole of ethylene. But here it is not complete. We have to still write the physical state. So carbon is obtained in terms of solid, hydrogen is obtained in terms of gas, and ethylene is also the gaseous substance. So this is the equation which we want, and its delta H value we require. And the equations which we have to use is nothing but, the first thing given is formation of water. Now, in formation of water, water will be formed from its element and in its standard state, that is hydrogen and oxygen in the gaseous form. Now, since it is formation of water, we cannot change the balancing of H2O. That means the equation will become as delta H, that is H2 plus half O2 is giving you H2O. Only then the delta H value is minus 286 kilojoule per mole. The second thing which is given is formation of carbon dioxide. So for formation of carbon dioxide, we will be using its element in its standard state, that is carbon plus oxygen is giving you carbon dioxide. No need to balance this equation, and the delta H value will be minus 393.6 kilojoule, which is there. The last thing which is given is combustion of ethylene. Now, combustion reaction means reaction with oxygen. That means it is C2H4 plus oxygen will give you certain compounds. Can I say it's a hydrocarbon? And hydrocarbon on combustion will give you carbon dioxide and water. Since it is combustion of ethylene, we cannot change the balancing of ethylene, and balancing other terms, we get the answer as 1 mole of ethylene will react with 3 moles of oxygen to give you 2 moles of carbon dioxide and 2 moles of H2O. Only then the delta H value is minus 1423.6 kilojoule per mole. So these are the equations which we have to use to get the above equation, that is formation of ethylene. So let's start the sum. The things which we have to get first is 2 times the value of carbon. Now, can I say carbon is there in equation number 2? But we want 2 times its value, and the value which is given is only 1 time. So we have to multiply equation 2 by 2. So multiplying the equation, the delta H value even gets multiplied by 2. So we got the first ingredient. The second ingredient which we want is 2 times hydrogen. And hydrogen, yes, it's there in equation number 1. But we require 2 moles and it is given as 1 mole. So similarly, equation 1 will be also multiplied by 2. As soon as the equation is multiplied by 2, the delta H value will be also getting doubled. That's minus 572 kilojoules which are there. Now we have left with only one ingredient, that is C2H4, but we require on the product side. And C2H4 is present in equation number 3, but in the reactant side. So we have to reverse the equation which are there. Reversing the equation, delta H value is also getting reversed. So let's check what are the things which we want. The things which we want is 2 times carbon, 2 times hydrogen, and 1 time the value of ethylene. Other things we do not want. So can I say 2 oxygen plus 1 oxygen, that is 3 oxygen, is getting cancelled by 3 oxygen here. 2 times carbon dioxide and 2 times carbon dioxide is also getting cancelled. 2 times water and 2 times water is also getting cancelled. So we have left with our choice of equation which are there. Simply doing additions and subtractions, we get the final answer as 64.4 kilojoules which is there. So this is how the sum has to be solved. Let's take quickly one MCQ based on that particular question. Question says, if you have been provided with 4 equations, what we have to find is enthalpy of formation of H2SO4 at 298 Kelvin, and we have been given 4 options. Can I say, since it is formation of H2SO4, we cannot change the balancing of H2SO4. and H2SO4 will be formed from its elements in its standard state as hydrogen plus sulfur plus 2 times oxygen is giving you H2SO4. So let's quickly check where are these ingredients present. The first thing which we want is 1 time the value of hydrogen. Can I say it is present in equation number 4? So equation 4 will be directly added. Second which we want is 1 time the value of sulfur. It is present in equation number 1, so equation 1 will be also added. But can I say adding equation number 1 and adding equation number 4, we already got half oxygen and 1 oxygen. That means 1.5 oxygen. That means in the total equation we require only 2 oxygen, out of which 1 oxygen and half oxygen is already there. That means we require only half oxygen more, and in equation number 2 we have an half oxygen. That means equation number 2 will be also directly added, which is there. Till the time we got all this reactant side which is there. Now we are left with only one thing, that is H2SO4, and that too on the product side. And yes, H2SO4 is present on the product side in equation number 3. That means even that will be directly added. But suppose if we add all the equation, the things which we want is okay, but the other things should get cancelled. Can I say sulfur dioxide and sulfur dioxide is getting cancelled? Sulfur trioxide and trioxide is also getting cancelled. Water and water is also getting cancelled. So simply addition of all the equation will get the final answer by addition and subtraction as minus 814.4 kilojoule which is there. So this is what we'll be covering in this module. Thank you.